All right, everybody, hello. Good afternoon, and welcome to our presentation today. So today we're going to talk to you all about building custom UI components with SLDS and Lightning-based components. So real quickly, we're going to do our introductions. My name is Jade Pennig. I'm Director of UX on the Framework Infrastructure team on SLDS.
And I'm Jesse Brack, Senior UX Engineer on the Lightning Design System Framework team.
Great. And of course, before we get into our presentation today, we have to mention our forward-looking statement, which is basically when it comes to Salesforce stock, base your decisions solely on announced products and not on anything forward-looking that we may talk about today. So first things first, I'd like a little audience interaction here. How many people in the audience have tried out the Lightning Design System before? OK, cool, good number of you. How many have used Lightning-based components?
Sweet.
Awesome.
Nice.
And then how many of you have used those tools to create your own custom components? OK, so still a good number. And then bonus question, how many people here are familiar with Lightning Web Components? Hopefully a lot after this week. So let's get into an overview of the things we're going to cover today in the next 40 minutes here. First thing, we're going to introduce the Lightning Design System. We're going to introduce SLDS, what Lightning Design Systems are. And then we're going to get into some of the code. We're going to create some layouts with the SLDS grids. We're going to compose using Lightning-based components. We're going to bring a component blueprint to life with SLDS and Lightning Web Components. And then we're going to share some essential SLDS best practices with you before getting into a quick live demo where we build a couple of custom components of our very own.
All right, awesome. Thank you, Jade. So before we start diving into talking about building custom components, we need to take a step back and first talk about the Salesforce Lightning Design System. Now, a lot of you already raised your hands that you know what the Salesforce Lightning Design System is, but whether you raised your hand or not, it's beneficial for us to kind of ask ourselves a very simple question. What is the Salesforce Lightning Design System? So if I was to ask you to give me a one-sentence definition of what the Lightning Design System is, what would you say? Saw a couple eyes get a little bit wider. Don't worry, I'm not going to call on you. I'm not that kind of presenter. But if you were to ask me, in order to answer that question, we have to take a step back and talk about design systems themselves. So bear with me. I'm going to get a little academic for a second. But design systems are sets of interconnected elements that are coherently organized in a way that serves a purpose. So in the world that we work in, these interconnected elements are typically your design patterns, components, static assets, guidelines, and tokens. And the purpose is to provide a consistent feel to your branding, look, feel, and functionality. So this is the academic definition of a design system. But how does this relate to my original question? What is the Salesforce Lightning Design System? Well, since we now have a good understanding of what a design system is, the following definition will make more sense. The Salesforce Lightning Design System, commonly referred to as SLDS, is Salesforce's very own custom living design system. SLDS keeps our user experience cohesive, familiar, and accessible across the Lightning platform. There's a unique characteristic of SLDS that makes it different from other design systems, and it's its implementation agnostic approach. So that's just a really fancy way of saying that SLDS doesn't care about the technology you're using. If you live in React, that's fine. If you live in Angular, that's fine as well. This website, getsLDS.com, will provide you a lot of good examples and documentation regarding the design system. And as a quick side note, all the links that we'll be sharing throughout the talk, we'll have a couple of slides that encapsulate all those towards the end of our talk. So cool. Now we'll dig a little bit deeper and learn about the elements that make up our Lightning Design System. These primary elements are design tokens, utilities, design guidelines, and blueprints. Design tokens are the heart and soul of our design system. These atomic elements provide us a systemized approach to defining values such as properties such as color, spacing, and sizing. We use design tokens in place of hard-coded values in order to maintain consistency and scalability within our apps. So in our example here, we've defined 3 design tokens. We have a background color token, text color, and spacing. Now, if you live in the Aura world and you've used our design tokens before, this may look a little weird to you, but perhaps this looks a little more familiar. This is a design token created in Aura. On the left, we are defining our design token, and on our right, we're using it within our style sheet. And here's the, here's the same design token created in Sass.
Oh, I don't know.
Same pattern, we define it on the left and use it on the right, but just this time, we're using Sass. So you might notice a recurring pattern here that we're both defining and using, but it's the same concept, but it's just a different implementation. It's still a design token. So that brings us back to what we saw earlier. This is also a design token, but instead of using Sass or Aura, we're defining our design token by creating a CSS custom property. Now, who's familiar with CSS custom properties? Okay, just a couple. I expected that. It's kind of new. If you're unfamiliar with CSS custom properties, you can think of them as native CSS variables. If you ever use Sass or less, you know about CSS variables, but CSS custom properties allows you to use CSS variables without needing to use Sass or less. It's baked into CSS itself, which is really, really cool. So looking again on the left here, we define our token by creating a new custom CSS property. And an important thing to note here, anytime you do create a new custom property, you must begin it with 2 dashes. That's a syntax requirement. If you don't use it, it will fail. And then the acronym LWC is our way of namespacing our custom properties within Lightning. LWC stands for Lightning Web Components, and we'll talk about that a little bit more if you're unfamiliar with that. Then on the right side, we're consuming our custom property. So this gets a little gnarly here if you're really unfamiliar with custom properties and you're more used to old school CSS. But we actually have to invoke a var function in order to use our custom property. And we pass in our custom property as an argument. And whatever is returned as the result will be our value. Now, again, this gets a little crazy, but it's not as bad as it seems. Once you actually start using custom properties a little bit more, it becomes easier with time. But why am I showing this to you? So the important thing here is during our talk, we're going to be using a lot of custom CSS properties. The reason we're doing that is because that is going to be the future of design tokens within SLDS. We want to get you familiar with it. But if you still live in the Aura world, that's fine. Because again, as you see here, all the concepts are the same. It translates to whatever context you're working in. So back to our token example. Whenever you're authoring your component styles, you want to use design tokens instead of hard-coded values, right? So in our example, we've created a component, and we've added the class myWidget. This class has a couple styling properties, background color, color, margin. And as you can see, we use design tokens instead of hard-coded values. When this is all said and done and it renders in your browser, the background color will have the RGB value there, which is black. The color for your text will be this white here, and so on and so forth. Now, the beauty of design tokens really begins to shine when the complexity of your system grows. So our example went from 1 component to 3. Now imagine you're in a world where you need to update the background color of your app, and instead of going into each individual component 3 different times and updating each background color, instead, all you would do is update the background color token once. That single change will trickle out to each component referencing that token and update its value automatically, which is pretty cool. But now imagine if we had 20 components or 40, and you didn't have design tokens. That would be a really gnarly world to work in and try to have to update all those by themselves, but thankfully we do have design tokens. Tokens give us consistency and scalability. Utilities. Utilities are special CSS classes that handle specific single-use situations, such as structuring layouts. A good example of a utility is the grid utility. This is a set of CSS classes that makes it easy to create flexible, mobile-first layouts when you're structuring your layout systems. When you are trying to build out a layout within your app, this is your go-to utility. I've seen a lot of people try to just go ahead and make their own layouts for custom CSS. You typically want to avoid that and use a utility in this case. Jade will be providing an excellent deep dive on the grid utility here shortly. Design guidelines. Design guidelines are best practices and principles that help guide and unify our decisions we make in SLDS. They are extensive instructions and knowledge around different things such as user interface patterns, markup, styling, voice and tone, accessibility, probably a couple other things I'm forgetting. It's very comprehensive. This is an example of one of our design guidelines that currently lives on SLDS right now. This is for the toggle element, and it tells you how to use it within a data entry interface. There's clear instructions of what to do and visual do's and don'ts. And last but not least, component blueprints. Component blueprints are sets of robust user interface elements that we use to construct our components and experiences. A component is comprised of semantic HTML, CSS, accessibility, and guidelines. Now, components are key to what I mentioned earlier, that SLDS is implementation agnostic. If you wanted to implement these blueprints into React, you can, not a problem. But you can also use an out-of-box solution that already exists today. It just so happens that out-of-box solution is called Lightning-based components. And we will be focusing on that heavily today. Whoops, went a little too fast, but here we are. All right, so Lightning-based components. Those are the building blocks that make up the user interfaces that run the modern Lightning experience. If you're building on the Lightning platform, this will be your go-to resource when you're creating user interfaces. Some of you already raised your hands that you're using them. Hopefully, that you're familiar with it and enjoying the benefits. However, as indicated by the name, these are base components. So they may not cover 100% of your needs. In that case, you're going to want to create your own custom element, hence why you're here. And we will be showing you how to make a custom element using SLDS blueprints, which you just learned about here shortly. This link will take you to the Lightning-based component site, where you have examples, good documentation, and even a code playground where you can test drive the Lightning-based components. And very quickly, we want to give you a glimpse of the future, LWC. Lightning Web Components is the next major evolution of our base components and how we implement blueprints. LWC is built on top of the concept of web components, which allows you to build real native components on the web without using with using web standards. That's very key, with web standards, without using things like React or Angular. This is too large of a topic to cover in this single talk, but we just want to kind of highlight it. And if you're interested in kind of working on things that are very future forward thinking and kind of cutting edge, this is the thing to look at. This is very cool. LWC.dev will give you more information. I highly encourage you to check it out. So with that said, everything I've shared with you so far lays a good foundation for the rest of this talk. I'm going to pass it back over to Jade, who's going to show you how to build custom components.
Great, thank you, Jesse. So now that you know a bit about the systems that we'll be using in the rest of the talk, let's dive in. Before we get into all of the fun with custom components ourselves, I want to spend a little time talking about layouts. Layouts are the most fundamental part of any design composition, from large to small. Having an understanding of SLDS's grid system can help you achieve pretty much any layout you think of. The grid system that SLDS provides is robust, mobile first, based in CSS Flexbox. What do I mean when I say mobile first? Mobile first is the concept of first building your design interface with the smallest viewport in mind, and then scaling your design up at certain breakpoints to respond to those larger screens. For SLDS, this means adding size and class prefixes for certain breakpoints, which you can see on the screen here. We utilize small, medium, and large keywords to designate responsive breakpoints for mobile, tablet, and desktop. To illustrate this message and to show off the power of the grid system, let's take a look at some code. So what you see here is the minimal code that you would need to utilize the SLDS grid, although at the moment it's not giving us much of value. The grid system is comprised of at least two structural elements. You have your grid container, which utilizes the SLDS grid class, and then you have your SLDS call, which designates a column. A grid container can have multiple SLDS call children, and it's by adding these columns and adding modifier classes to them that we unlock the real power of the grid system. So let's go and add a second column to our grid. As we can see, when I added that second SLDS call, the layout responded and set that second column next to the first. So while this is expected, it's not quite what we're going for in a mobile layout. Mobile layout, when we have multiple columns, they can get really squished and really crunch things up. So let's turn this into a responsive grid system using the classes we talked about earlier. So when we add these size-based classes, we start to make intentional declarations for how we want to lay out our content. But something seems wrong here. We're setting the 1 of 1, which is spreading the column out to the width of the container, but we're not breaking, and things are kind of looking broken here. So what's missing? SLDS wrap. So once you get into kind of these compositions, and once you start thinking about layouts responsively, SLDS wrap is kind of this essential class that you need that will allow the breakpoints to kind of break into multiple rows when you designate them. So when we have this in place, now we have the layout effect we're going for. And now for the fun part, let's make it responsive. So for desktop, we add additional sizing classes specified to change at the size-based conventions that we talked about earlier. So we're going to use the large size class here, so we can have a suitable breakpoint when we get to the desktop layout. The grid system is divisible into 12 columns, as you can see with our 8 of 12 and 4 of 12, but those class names also pare down. So declaring sizes like that are equivalent to declaring sizes like this. And SLDS supports divisor values from 1 to 12. So when you're building your layout, it doesn't always make sense to use like 8 of 12 or 4 of 12. The math can get a little harder to make sense of. So if you kind of have a simpler layout, it might make sense to use these smaller divisors, because a really important takeaway from this is that once you start doing these responsive sizes, you really need to make sure that that second number, which is the divisor, adds up to the first number, or the total of the first number. You don't want a situation where you have a 3 of 4 and a 2 of 4, because that's not going to give you, the layout that you expect and could break in unexpected ways. So you always got to think about these and make sure that the sum matches the second number. So it may seem like we spent a lot of time right now just talking about grids, but really we've just scratched the surface, because there's so many things that you can do with it. You can add responsive column reordering, which means you can change the actual order of the columns as they respond to different breakpoints. You can do grid nesting. You can do alternative layouts like right to left. You can support column, top down, bottom up, alignment modifiers, pretty much anything you can do with CSS Flexbox. We have a utility for to align it to our SLDS grid system. So, this could be a talk on its own. And in fact, our very own Brendan Ferrua, who's sitting in the front row here, he did a talk at TDX this year on this topic specifically. So if you want to hear more about that, there's a YouTube link here below. You can take a screenshot of that. I tried to get a better URL, but I was unable to do that. But here you go. And then, layouts are fun, but when we think about them visually, they don't really give us a lot on their own. They're kind of placeholders for the elements we care about, which are, our buttons, our form inputs, all the visual pieces. So for those needs, we can tap into the power of our Lightning-based components. And as we mentioned earlier, base components are the living interactive components that are created from our SLDS component blueprints. They're documented on the Salesforce developer website, and it's a great resource to go to get documentation. So we're going to build onto that 2-column layout that I kind of built previously, and we're going to start adding some base components into that mix. So 2 things I want to add. I want to render a tab set in that main area, and I want to render a box in the sidebar. So luckily for me, base components has both of those things already. So when I go to the developer website, you can find the documentation, and there's live code examples of all of the base components, which is really nice, because then you can actually, in the live code editor, you can kind of play around and change things and see how they respond. So getting started is as easy as copying and pasting from their live code examples. So I'm going to take that, I'm going to kind of copy from the website, I'm going to paste into my code here, and then we can move forward. So I copied the Lightning tab set example over to my project, and instantly, without doing any more work, I have a responsive, living, rendered component on my screen. That's the power of Lightning and base components, because I did no work to kind of make that more link appear on mobile. It just responsively adjusted to the viewport width. So let's go ahead and find the card element that we want for our sidebar. And then we throw that, copy, paste that code in there, and then we have our sidebar, and then we have, it's still responsively, it's behaving responsibly, and it's changing as we expect it to. So at that point, we kind of go ahead and we'd fill that with our own content and kind of flesh out those components. So what happens if I can't find the user interface item that I want in the Lightning-based components? Base components, the word base is in there for a reason. It's kind of these primitive, very plug-and-play components meant for using in compositions. So before you go and just build your component from scratch, the Lightning Design System's component blueprints have a lot more component blueprints that are expressed in base components. So the first place you should do is go look there and see if there's a component blueprint that kind of aligns to what you want to create. And if there is, we're going to go ahead now and we're going to show you how to do that. So for my example today, I have determined that I want my interface to have an alert-style dialog that reports certain statuses. I've determined, based on browsing the SLDS component blueprints, that the scoped notification component is the best to suit my needs. So the SLDS component blueprint page for the scope notification blueprint shows me that HTML structure and all the accessibility requirements for each variant and example. So for our purposes today, I'm going to create this component as a Lightning Web component, both for simplicity, but also to showcase what's to come with LWC. As Jesse noted earlier, Lightning Web components harness the power of web components on the Salesforce platform. I know that personally, I'm excited to be writing standards-based code on the Lightning platform. So I open up my code editor, and I dump the component blueprint code in. Well, now what? So one of the first things we want to look for when we implement a component blueprint are other components that exist within that composition. So we can see here in our scope notification component, we have an icon. And icon is something that exists as a Lightning-based component. So wherever we see these things, wherever we see things that are other Lightning-based components, we should utilize those where we can. So we're going to replace this chunk of code with this. Composing our systems with the base components are an excellent way to create interfaces that adhere to the design system standards, and you subscribe to future component updates when you do this. You no longer have to maintain that component yourself. So the next thing we want to address, bringing our component blueprints to life, is the component messaging. The example kind of came with this paragraph here, but that's not what we want for every case. We want it to be dynamic for each instance of that component. So we replace that markup with a variable. And then in our Lightning Web Component world, we kind of turn to our JavaScript, and we just declare that as an API. We have our API decorators. Thank you. So we have our API decorator there, and then we set that message, and that kind of tells the component, like, hey, accept a message parameter when you invoke this component. And then I put a placeholder there just, for good measure. So one more thing we have to do here, if we look back at our component blueprints, we'll notice that there's a couple different examples they have. And these are examples of theme modifiers. So we kind of go through the different ones, and we see a light, a dark, and we kind of want to see, we look at the blueprint code, and we can see that what changes, right? So that class name modifier gets added for that scope notification dark. And then we also have this kind of icon text default when we have the light icon. So we need to bring those to life, too. So what we're going to do is we're going to introduce a theme parameter so we can declare which theme we want to use. And to add some logic to that, we're going to create this scope notification getter class or getter function that will massage, add that light or dark modifier class depending on what theme we've input. And then the other thing we need to do is we need to set that icon variant. So it's kind of a little bit, this required a little bit of looking into the Lightning-based component documentation to see how they did their theming. And then what they want is they want an icon variant of inverse. So we kind of program that up, and then we go back to our HTML, and we stick our getter functions in there, and that'll give us kind of the output we expect for both that class and that variant. So now our component is kind of fully living, and we can bring it into our composition, and we can call it. So you can see here I'm calling the scope notification, and I have that message, which is my custom message, and I have that theme, which is that custom theme I want. And at the end of the day, I get this on my screen. So we picked an easy component to kind of show you how to bring to life. Most components are going to have a lot more moving parts. And before we wrap up this section, there's a few additional things I want to point out when it comes to bringing these component blueprints to life. Because it's not always obvious which HTML attributes are static, which you don't need to change, and which ones are things that you actually are going to need to program out and bring to life with component logic. So the first and most obvious thing is the ID. Anywhere in our blueprint code where we have an ID reference, that's going to need to be replaced with a unique identifier for that component. And I'm sure we're all familiar with IDs and how they have to be unique to the page. So that requires a bit of logic. We also have attributes like ARIA controls and ARIA describe by, and these are ARIA roles that refer to other ID references. So wherever you see these things, hey, they kind of actually have to hook up to another living element in my component, and they need to respond to something real. Then there's also Boolean-based ARIA roles, like ARIA hidden, pressed, expanded. There's a lot of these. This isn't an exhaustive list, but these are just things that when you see them in your blueprint code, you know that before your blueprint is alive and living and fully functional and accessible, these things need to be programmed in. The same with tab index. We see this a lot with interactivity. And then classes as well, as you saw in our example, we had to kind of change that class based on certain inputs and modifiers that we wanted to do. So like I said before, there's a lot more of these things to look out for. I don't have enough time to talk about every single thing you might encounter, but just keep in mind that blueprints are blueprints, and that they need to be fleshed out as you create your components. So let's say your needs aren't yet covered, and you want to create your own component. So the first thing you should do is evaluate and just explore if there are viable alternatives for what you want to create. And design systems are about consistency above all. So if your component just varies a little bit from what we have, it's probably better for the consistency of your system to try to use things that already exist. But if you are sure you need a new component, or you want to make a component that's a composition of things, think about how it will behave responsibly. When you build with the system in mind, work with the system, not against it, and use base components where you can. And use our SLDS tokens for things like color, sizing, spacing, They all help keep things consistent. And the last thing you do is you need to make sure that you've adhered to the best practices that we're going to talk about next.
Awesome. Thank you, Jade. So I'm going to share with you some best practices that you can take with you and use today when creating your own custom components and working with SLDS. So let's jump right in. Best practice number 1, customize instead of overriding. Whenever you need to change something about SLDS, perhaps maybe color, spacing, or sizing, avoid using one-off solutions that override the system. How do you know you're overriding a system instead of customizing? Well, a good rule of thumb is if you're writing any styles that cancel out SLDS styles, you are overwriting, not customizing. So in this example, on the left, we have a generic SLDS component with a padding that is set to a design token. On our right is our custom CSS. We've overridden the padding value with our own hard-coded value of 16 pixels. Now this might seem like a small, innocent change, but there are a lot of negative outcomes that can come from this. First of all, whoops, too fast. Whatever, okay, first of all, so we've lost our design token. Like, I wouldn't shut up earlier about design tokens, and now we've just gotten rid of it. Like, we've lost all the advantages that we were talking about earlier, and this component is now disconnected from your system. Second, we've created an inconsistency. So this component now is a possible regression in the future if the value of this token is ever updated. The rest of your app will update, but this component won't. And lastly, you have to manually update this component if you want to change it in the future. That's really tedious, and it also adds tech debt. This is a better way of handling this situation. So that we noticed when we were looking at our generic SLDS component, it was using a design token. Let's take advantage of that. Let's assign the 16 pixel value that we were wanting to the design token instead. Now we are feeding into the design system, and we are customizing, not overriding. And you might be wondering, okay, that's cool, that's awesome, but what else is customizable? And that's a good question. And there are a lot of things. So you can customize colors, typography, spacing, layout, sizing, and much, much more. So whatever you're looking to customize most likely already exists. It is one piece of documentation away. That's less work for you, less one-offs, and less tech debt. The second best practice, be deliberate with your design tokens. So it's critical that the token your component is using aligns with your component's needs. In our example here, we have a component called myCard, and it needs a margin. Since you're awesome and you're embracing the design system, you know you need to use a design token instead of a hard-coded value. So you start digging around in your design system, looking for the perfect token, and you find one, button spacing, 1 rem. Awesome. You plug it into your component, you pat yourself on the back, and you call it a day. Good to go, right? Or does anybody else notice something kind of weird here? Well, we have an incorrect token usage here. If you notice the token's name, it's called button spacing. It's prefixed with the word button. That means it's scoped to button components only. Our component is a card. What we've done is use a token that is exclusive to other components in our component. This will cause unexpected regressions in the future if we don't correct it. How do we correct it? Good question. So we find a token that not only has the value that we're looking for, 1.5 rems, we also look for it has the proper scope. And what I mean by scope is it's not scoped to another component like how the button token was. This one is not scoped to anything. We generally call these global tokens. So we would use this token instead, and this puts you in a lot better shape. Okay. All right, my favorite best practice, and our last one. Style smarter, not harder. This is probably the area developers bang their head against the most. Writing good CSS is hard enough, but then you try to write CSS within a design system that's constantly growing, living, breathing fire, whatever. It's bound to cause problems. So if you follow these tips that I'm about to give you, you'll be writing more resilient CSS and system-ready CSS in no time. So let's jump in. The first suggestion I have for you is writing good basic CSS hygiene. So this will essentially apply to writing better CSS in general, not necessarily to SLDS. So first up, and this is going to be kind of rapid fire for the sake of time, is first, don't use type selectors with your classes. It raises your CSS specificity and creates a dependency on your markup that's likely to cause issues in the future. Second, avoid long nested selectors. If you're writing or seeing CSS like this is a major red flag that your CSS has specificity issues, and it's only going to get worse. Next, avoid the universal selector. It looks cool, but its range is too broad, which makes it too unpredictable. You're setting yourself for styling conflicts in the future. And lastly, don't use the important declaration as a hammer. There's very, very few exceptions to this, but this is also a red flag. If you're using this, you need to actually ask yourself why you're using it. There's a deeper problem there. So don't do that. And lastly, whatever you do, don't ever, 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 please don't ever write CSS like that. That is like the final boss of bad CSS. It's terrible. I'm just going to let it wash over you for a second. All right, let's go.
Everyone's like, wait, no, don't.
The next thing we want to recommend is not using design system classes in your CSS. So separation of concerns here is very important, and we recommend keeping SLDS as clean and pristine as possible. But if you do run into a situation where you feel like you do need to write custom CSS, abstract out your styles into their own class. Do not use SLDS classes. So for example here, this is our custom CSS. We have SLDS scope notification, but I want to reemphasize, this is not an SLDS class. This is our custom CSS. We are just using the same class, so we're essentially creating a dependency on the two. And that's going to set you up for failure in the future. A better way to handle this is take the styles that you want to add to the system, abstract them out into your own class, and add that class to the component that you're trying to affect. So in this example, we've created a MyStyle class, added the styling we were trying to add before, and added that to the actual markup of the component that we're looking to affect. This is way, way better. And an important advantage to this is when you're looking to update SLDS, your migration will be far less painless. All right. So the next one is avoid using contextual selectors. Anytime you're writing a CSS that is dependent on a parent selector, you're creating dependencies that will possibly fail in the future, and you're also increasing your CSS specificity. So a better way to write this is to write flat CSS. Use singular selectors. This will go a long way in making your CSS more predictable and modular. SLDS uses the bend methodology to help keep our CSS sane. If you're new to writing CSS like this, I highly recommend this as a starting point. It will get your feet pretty wet there. And lastly, do not use absolute values. The CSS you write should be inherent to the flexibility of the web. So let's walk through this example and change each value to kind of show you what I mean. So first, we change the font size to a rem. A rem is a value that is relative to the root element of the page, and that is typically the HTML element. The reason we do that is because you can create a typographic scale that will scale nicely once you just change one value. And then we change our margin top also to a rem. This keeps our spacing and vertical rhythm consistent when we do update that typographic scale. And to fix the width, does anybody have an idea what we do? Okay, all right. We remove it. So layout should not be a concern of your component. That's what things like grid utilities are for. Your component should always expand to fill its container. It's very important. Oh, sorry. This was supposed to be a bonus question. If you're wondering why we weren't using design tokens, well, we should be. This would be the most correct solution. All right. So to recap. Best practice number 1, customize instead of overwriting. Best practice number 2, be deliberate with your design tokens. And best practice number 3, style smarter, not harder. And I'm going to abbreviate this next slide for time a little bit, but I highly recommend you checking out this talk, the top 10 code issues revealed by the SLDS Validator. It is tomorrow. It will go over a lot of the best practices that I just shared with you. And with that, I'm going to turn the stage back over to Jade, and who's going to help close this out.
All right, so I am going to maybe rush through this demo here real quick. We don't have a ton of time, but what we want to do today and kind of what the intent was to build this component, which is kind of based off my homebrewing fascination, dreams I want to do when I leave Salesforce. So we kind of have here, we have like an SLDS. We have our scope notification that we kind of made earlier on. We have a media object that kind of lays out that image alongside content inline to the right of it. And then we have some content below. So, and then, like the idea is that we would lay it out in a responsive grid. I don't think we'll have time for that, but that's kind of the concept there is we'd use those grid utilities from before. And I'm going to really skim this over. I'll have time for questions at the end. But kind of setting up our development environment, we have VS Code. We're kind of setting it up at the LWC way. We have our SFDX CLI. And we have Prettier, things that kind of help us make our development fast and efficient. So let's get into our demo here. And the first thing that I'm going to do is I'm going to escape out of here, and I'm going to hope that this mirroring thing works. There we go. All right. So we're going to go into our code editor, and we're going to start up our LWC server. So SFDX. And then this is the Force Lightning LWC start. We're going to run that and let it boot up here. And that's going to give us our local development environment. So we can go ahead and we can click on this local host. And as we load this up, this is going to have our home page. So since we don't have a ton of time, I'm actually just going to go, and we can see our custom components that we made so far. So I'm going to go into our code editor here. And I'm going to create our new component, because I haven't actually created our fermenters component yet. Yep, OK. So we're going to go here, and I'm going to do SFDX, create lightning web component. I'm going to give it a name, and we're going to call it fermenter. And I'm just going to put it in the default directory there that it wants to put it in. It's going to create all those files for us, right? So it created a JavaScript file, HTML file, and this meta file. Familiar with LWC, you should kind of be familiar for you. And then what we're going to do here real quick is I have my data stashed away in my fermenters object, my fermenters component here. So I'm going to just copy that down. So as I develop this out, I can kind of have some content that I'm working with. So API, because eventually this is going to be the input parameter that we use for a component. So API and then fermenter is this data object. So we're going to save that up, and we're going to go to our HTML. And for the sake of time, I have copied and pasted some code here. So we're going to go and paste this in, which is our namespaced wrapper component and kind of our box that we're going to put stuff in. And then we're going to go real quick. We're going to Lightning Design System, because I need that media object. So search is a great utility on our website. And we can go. We get to the media object page. And as you get more familiar with SLDS, you kind of get a better sense of what components that exist and what you can work with. So copy and paste that HTML. I'm going to remove that demo element, and I'm going to remove everything inside the media figure, and I'm going to remove everything inside the media body, because that's what I actually want to populate with my content. So again, copy paste demo magic here inside the media figure. I'm going to put my image and save that. And that's what Prettier is so nice, because it just formats things for me. And then my media body. And I'm going to paste that in there, and we're going to save it, and we're going to go back to our local development server, which is refreshed automatically behind the scenes, and I see my fermenter. So there we go. I have it. Oh, I need my description. So I'm going to add my beard bio, and I'm going to put that right under my media object. So there we go. And if we kind of want to do a little bonus thing real quick, since I'm going to kind of skip the layout part of it, I am going to kind of add this, add my scope notification component. Oh, and of course, I'm not going to have the right data for it, but. So we're going to add that, and then we're going to kind of quick hack our data and then just say, show bottle message. I'll turn it true out of here. All right, and then we go back to here. We can see, hey, now we have our scope notification message, and then we also have our image. So, like the next step is to kind of put that in a grid so it can respond. But we kind of reviewed that in the earlier section. So I'm just going to go ahead, since we only got like a minute and a half left, and leave that off here, go back to our presentation, and just kind of wrap things up. And I appreciate everybody for being flexible here. All right, cool. So we're back. All right, so to wrap up everything we talked about today, because we talked about a lot. We talked about design systems, what they are, what SLDS is. We talked about how to construct layouts with CSS grids. We talked about lightning-based components and kind of how you can use those to compose with. We touched on building out a SLDS component blueprint, and you kind of learned about what's required to bring those component blueprints to life. Shared some essential SLDS best practices, and then we also had our quick little live demo. So some important additional resources, really important links to know. These are the three main things that we talked about today. We have our Lightning design system, we have our Lightning-based components reference, and then we have our Lightning web components, which is a great reference for learning more on that. And then we have a couple trailheads that we kind of hope you go through as you learn more about these concepts. Give you all a second to take some screenshots. And then we also have some additional resources. We have a reference here to Ambreen and Danya's talk. Really interesting stuff, issues that we see in the wild, we see in the real life with how people use SLDS. And also come visit us at Camp Design and then Trailhead Tools booth, all that. Also join our user research program. It's great. It'll be, it's a great way to help kind of share your feedback and to help shape the future of our products. And then we have no more time left for questions, really, but we will be available kind of off stage and out in the hallway for any questions that y'all may have. So thank you.